We're going to be working with square root functions.
Oh, yeah.
If you remember, long time ago, about a week or so ago, we asked you to graph something like this.
Sure, it doesn't work.
And when we graph that function, anybody remember what it looked like?
No.
Was it the parabola? Is that what you're saying?
It was something that looked like this,
Okay.
called a parabola. Right? Has a vertex on it. Remember, we spent all that time putting it in vertex form so that you could find out where you could put your vertex, and then we decided whether it went up or down and all that.
Yeah.
Well, this is already kind of in a vertex form, which means the vertex is at 0, 1, goes up, and it's a normal width opening because the number here is a 1 that is multiplied by. Okay? What we are going to work with now is the opposite of that, or the inverse of that, which means the inverse operation to squaring something is the square root of it.
Ooh, Jacob.
Now, if I asked you to graph that, in some ways it's going to look a little bit like this, but yet in other ways it looks totally different. The graph of something like this that has a square root in it looks something like this. Kind of half a parabola laying on its side. Okay? Now there are a couple of things that go along with that parabola laying on its side, or half of a parabola, that we have to take into consideration. First of all, with a parabola up here, you could worry about this x being positive or negative, correct? And it wouldn't make any difference. I mean, it would help form your graph, right? But down here, we have to worry about this x being always bigger than 0. So the value inside the radical you know what I mean by radical?
The sign, the square root sign.
Yep. The value inside the radical always has to be, as somebody just said, positive, or it has to be greater than or equal to 0. That value always has to be greater than or equal to 0. Always. Always, always, always. Can't be negative because can I find the square root of a negative number?
No.
Well, I can. It involves an I, doesn't it? Which is imaginary. And did we ever graph imaginary numbers? Nope. Don't really have a way that we've discussed, okay? So one of the things that they want you to do with a problem like this is they want you to determine the domain and then also determine the range. So I need to determine the domain and I need to determine the range. So let's say that I had this function down here again, y equals the square root of x. To determine the domain, All you have to do is set the radical to greater than or equal to 0 and solve. Well, the only thing that's in the radical right now is x. So to do that, I set the radical, that stuff that's inside the radical, x greater than or equal to 0. That's pretty simple, isn't it?
That's the domain?
Right now, that's your domain. Because it's already solved, isn't it? So it becomes, if I wrote it legally, x where x is greater than or equal to 0. That's the domain. And that's how we express it.
Or we can keep it x or greater.
What?
We can keep it x or greater than x or greater.
Yeah, I'll let you get away with it. But you will see the answer is generally written this way.
That's just a straight line.
Yes. It means where. Okay? So finding the domain should be relatively easy.
Yeah.
Correct? How do I find the range?
Same thing, opposite?
Nope. Find the range, I set up an XY table.
These are fun.
Starting with your domain value that you just found here, which means that it's a 0, isn't it? Put a 0 in for the x. What's the square root of 0? 0. Right? What's the next integral value? It's a 1, isn't it? Isn't 1 greater than or equal to 0? So what's the square root of 1? 1. Right? I'm going to put down here so that we can keep track of it. So I'm going to put in a 2. So now I have y equals the square root of 2. What's the square root of 2? You better get your calculator out and find out.
Not 1.
Can't be 1, because that means 1 times 1 is equal to 2.
Yeah, that was
I think you guys have calculators, you have Chromebooks, you have everything else at your disposal. Which means you have your phones. 1.414.
Whoa.
What's the next value? 3. So then I'd have y equals the square root of 3. I believe that's about 1.7. Is,
4 is 2.
huh?
4 is 2.
I think the square root of 3 is 1.7 something.
1.73205.
Okay? 4. So now I'm looking for y equals the square root of 4. And Jacob's already told me too. What can you say about the range, or the domain? For this problem, the lowest it can get is 0, isn't it?
Yeah.
And it's going to keep on going to infinity? Because the bigger my x's become, my y is going to keep getting bigger and bigger and bigger? Okay? So the range would be where y is greater than or equal to 0. In other words, the smallest value right here. And it will go to infinity. As the x gets bigger, the y will get bigger. Okay? We all right with that? Yeah. Okay, let's try another problem.
Are we just doing the numbers?
No.
first thing I want to do is find the domain. And what do I do to find the domain?
Set the radical greater than 0.
Set the radical, that whole radical, the value inside of that has to be greater than or equal to 0.
That'd be just x plus 3, right?
So I'd have x plus 3 is greater than or equal to 0.
What about that 1?
Not worried about it yet. So the x has to be greater than or equal to a negative 3 because I subtract 3 from both sides. So the domain would be x where x is greater than or equal to a negative 3. I haven't gotten it fixed yet, no. It hasn't come back. Sorry, it hasn't come back.
Kids these days.
So how do I find the range? What was the process?
The range, x, y table.
So to find the range, I set up an XY table.
Then put 0 in here.
Nope.
Or no, negative 3.
I put, the first value I put in is my range, or domain value that I found.
Negative 3.
So I put in a negative 3. What's a negative 3 plus 3?
0.
What's the square root of 0?
0.
What's 0 plus 1?
1.
One.
What did you do? Yeah, could you say what you just did?
Okay? I took the negative 3, put it in for the x,
Oh.
right?
Oh.
What's a negative 3 plus 3?
0.
Square root of 0 plus 1. What's the square root of 0? You said it was 0.
Yeah.
I then add 1 to that, which gave me 1.
Okay. Go to negative 2.
So I go to a negative 2.
Then 2 plus 3
So if I did my work over here, I'd have a negative 2 plus 3,
is 1.
which happens to be 1 plus 1,
But the square root of 1 is
1,
plus 1.
plus 1
1.
gives you 2.
I bet the next one's 3.
I bet it's 9.
Bet it's not.
Nice try.
So I put in a negative 1, so I'd have a negative 1 plus 3.
When we're doing this, do you want us to leave it the same? What you're doing right now?
I don't care. If it makes it easier for you to do, sure. If you can do it in your head, do it in your head. What's a negative 1 plus 3?
2.
So I'd have 2 plus 1. What's the square root of 2?
1.414.
So I'd have 1.414 plus 1.
2.414.
Correct?
Yeah. And 0.
So I put in a 0. If I did that, I'd have 0 plus 3 in the radical plus 1. What's 0 plus 3? The square root of 3
1.7.
plus 1, and we said square root of 3 was 1.7 plus 1, 2.7.
Yes.
Can we stop there?
No.
Sure. If you can see the pattern that the lowest range that I'm going to have is this number, isn't it?
No.
Right?
So why did we go all the way to 2.1?
Why not?
Well, I mean, if we're using the first one, isn't there no point in going?
So that you can see the pattern, Tyler.
Oh,
See if there's a lower number.
Okay? Is the biggest reason for doing that.
Okay.
Yes, you are right, I could stop here, but do I know what's going to happen when I put in a negative 2?
No.
Until I can recognize that pattern, that's why I do that.
Okay, I got you.
So the range would be y, where y is going to be greater than or equal to 1.
Oh, man. Good job.
Does that make sense?
Yes, sir. The text isn't that bad.
Actually, it isn't that bad, is right. So your assignment will be page 427. 13 through 28 all.